All right, let's move forward from what I think is a little bit the easier stuff with quadratic functions into graphing and modeling these. And throughout this lecture, I'm going to give you guys some recipes, so pay attention to the recipes, try to pick up on the steps of what you need to do to solve the problems in the homework. All right, think of quadratic functions as projectiles. These are typical U-shaped, we can say frowns or smiles, but they're very common in real life, especially in sports. All right, so what are some characteristics of graphs? This is going to be the lingo, the vocabulary of this week. Okay, so the axis of symmetry here is what cuts the parabola in half. It's a vertical line, okay, and this blue dot, that's called the vertex. Okay, so the vertex given a u is going to be our minimum. Same thing, vertex is the minimum. And if our a, leading coefficient, is negative, then we already know from a previous lecture that this actually flips the parabola upside down and reflects it over the x-axis. We still have an axis of symmetry that cuts our parabola in half, and we have this blue dot here, the vertex, which is now a maximum. So the vertex is going to be an extreme value. It just depends on the shape of the parabola, whether it's going to be a minimum or a maximum. All right, relating solutions of the quadratic equation. All right, so you guys solved quadratic equations back at the very beginning of the semester. You did the negative b plus or minus square root of b squared minus 4ac all over 2a, right? So what do we get from that? All right, well, we get, remember, we get, and I'm going to write we have negative b over 2a, all right, plus or minus the square root of b squared minus 4ac all over 2a. All right, all I did was write the quadratic equation as two fractions. All right, and negative b over 2a should look really familiar to you now. Yes, that is the x-coordinate of the vertex. And to each side of this x-coordinate, what are we doing? We are adding and subtracting this square root, or the discriminant, divided by 2a. That is this distance right here that we see on either side of the axis of symmetry. All right, just so you understand that, all right, if I want to solve the quadratic equation, I'm going to get solutions. What are these solutions? They are x-intercepts. Okay, how am I going to get these x-intercepts? I'm going to get the x-coordinate of the vertex right here, and then I'm going to add and subtract this discriminant over 2a from each side of the x-coordinate of the vertex, and I'm going to get my x-intercepts. I know that's a whole lot of math lingo. The key is just knowing that solutions of the quadratic formula give us x-intercepts. All right, graphing the quadratic function when it's in vertex form. All right, so here's our vertex form. We know a is the leading coefficient, all right, that's either going to make the parabola upside down or right side up, and then hk, those are the coordinates of our vertex. All right, first we're going to look at a. We're going to determine whether the parabola opens up or down. We're going to grab our h and k and get the vertex. And we're going to find our x-intercepts. So we're going to set that quadratic function equal to 0 and solve. All right, again, that's the English of this. Set the function equal to 0 and solve for x. And then lastly, we're going to find the y-intercept. And the way we find the y-intercept is we plug in 0 for x. Okay? And then lastly, we're going to plot the intercepts in the vertex. All right, pay attention to me, guys. In my math lab, you have to plot the vertex first. Then, after you plot the vertex, you can plot the x-intercepts or the y-intercepts or whatever you want. Okay? All right, so let's go through it with an example. we have f of x equals negative 2 times x minus 3 squared plus 8. All right, a is negative 2. All right, what does that tell us? It tells us that the parabola is going to open down because a is negative. All right, we get h equals 3. Keep in mind its opposite sign, so h is a positive 3, and k is 8. So that gives us a vertex of the coordinate 3, 8. All right, let's find some of the intercepts. Now we need to solve for our x-intercepts. To do so, we are going to set our function equal to 0 and begin trying to solve for x. All right, so how do we do so? Well, the first thing we need to do is move the plus 8 to the other side. Why the plus 8? Because it is the furthest away from the x. So since addition is in front of it, I'm going to move it across the equation by subtracting 8. Then, my next step is going to be to somehow get rid of this negative 2. I need it on the other side. Why the negative 2 and not the square? Because the negative 2 is still the furthest away from the x. Okay, so now we need to move the negative 2, and I note that the operation between the negative 2 and the parentheses is multiplication. And the opposite of multiplication is going to be division, so I'm going to divide both sides by negative 2. In doing so, I now have 4 equals x minus 3 squared. Now at this point, some of you are probably going to think, oh, I need to FOIL the x minus 3, or I need to do something with my parentheses. And in fact, we don't. We just need to now undo the square. And so what operation do we have that undoes the square? It's the square root. Now when I square root my left side, or my right side rather, with the parentheses, I certainly have to square root my left side as well, or my 4. But when I square root the right side, or the number as it is, I have to put a plus minus in front of my square root of 4. Well, why is that? Because you know when I simplify, I'm getting plus or minus 2 equals x minus 3. Well, note, obviously 2 times 2 is 4, but also negative 2 times negative 2 is 4. And then finally, I can take what I have here left and say x equals, by adding 3 to both sides, 3 plus or minus 2. Noting the plus or minus stays in front of the 2. Well, many of you get confused as to what this plus or minus means. No worries, it just says, hey, we need to do both operations. We need to do 3 plus 2, which equals 5, and we need to do 3 minus 2, which equals 1. Therefore, we have 2 x-intercepts. So we have the x-intercept of 5, 0, and we have the x-intercept of 1, 0. We are almost able to graph our quadratic function. The last step is going to be to solve for our y-intercept. So to solve for our y-intercept, well, that's when x equals 0. All that means is we need to plug in 0 for x, okay? Note I am solving by plugging in 0 for x. I am not just taking this plus 8, which so often you guys are tempted to do. No, I'm actually going to solve this. And please excuse my dear Aunt Sally has reared her ugly head here. All right, so what do we want to do first? Well, do we want to multiply by the negative 2 first, or do we want to square first? And in fact, we want to square first because it's please excuse. Okay, so we need to square negative 3 before we think about multiplying by negative 2. Now we can multiply by negative 2. And finally, we can add negative 18 and 8 to get negative 10. Thus, our y-intercept is going to be 0, negative 10. Okay, well now it's time to graph our quadratic function that is in vertex form, given the y-intercept of 0, negative 10, the x-intercepts of 5, 0, and 1, 0, and if you recall from the previous slide, the vertex of 3, 8. All right, you guys, so let's do it. Let's graph the quadratic function in this example. Okay, let's graph our quadratic function that's in vertex form. Recall, this negative a tells us that our parabola is going to open down. All right, and if you also recall, our vertex was at 3, 8. So I go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my vertex. All right, and then from the last slide, we found our x-intercepts to be 1, 0, and 5, 0. And we found our y-intercept to be 0, negative 10. Okay, now using this, we can graph, or connect the dots, so to speak, but we can graph our parabola. Let's try this again. And so by connecting the dots, we can see that we have our parabola that opens down with a vertex of 3, 8, x-intercepts of 1, 0, and 5, 0, and the y-intercept at 0, negative 10. All right, let's also go through these steps, but when we're given general form of the quadratic function. So again, here we're not in vertex form. We're given the general form of ax squared plus bx plus c. So what are we going to do? All right, again, we're going to look at A and determine whether the parabola opens up or down. We're going to use what's called the vertex formula to find the vertex. So negative b over 2a will give us the x-coordinate of the vertex. We'll get that number, plug it into our quadratic function to get the y-coordinate. And like we just did, we're going to find any x-intercepts, all right, by solving f of x equals 0 or letting y equal 0. And we're going to find the y-intercept by plugging in 0 for x. All right, so very similar steps, just a different form. All right, and then lastly, we will plot the vertex first and then our respective intercepts. All right, so here, a equals 1, what does that tell us? That tells us that our parabola opens up, okay? And we have b equals 4. All right, so given an a equals 1 and a b equals 4, we can get the x-coordinate of the vertex. So negative b over 2a is just going to be negative 4 over 2, or negative 2. All right, again, that's the x-coordinate of the vertex. All right, so I need to get the y-coordinate of the vertex. How am I going to do that? I'm going to take negative 2 and plug it into my function. All right, so you can see I do negative 2 squared plus 4 times negative 2 plus 1, which is going to give me negative 3. So my vertex is negative 2, negative 3. Okay? All right, now let's find the intercepts. Now we need to solve for the x-intercept. So again, just like we've been doing, we're going to set our function equal to 0. And how do we solve this quadratic equation? Hopefully you can recall from chapter 1 that we're going to use the quadratic formula, where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so quickly, what are our a, b's, and c's? From the last slide, we know a is 1, b is 4, and we can see that C, our constant term, is 1. And so I'm literally plugging 1, 4, and 1 into my quadratic formula, and I get negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we can simplify this a little bit before we need to grab our calculator. We have negative 4 plus or minus the square root of 16 minus 4, which is 12, all over 2. When we plug these into our calculator, recall first we will do negative 4 plus the square root of 12 all over 2. And like I said, when we type this in our calculator, what we're going to get is roughly, I should put our little tildes, roughly negative 0.3. So we have our x equals negative 0.3 over here. So now I'm going to subtract in my numerator. And when I plug this into my calculator, what I'm going to get is, again, roughly negative 3.7. So we have solved for our x-intercepts. As you can see, we have negative 0.3 and negative 3.7 after we use the quadratic formula. Now we need to solve for the y-intercept. All right, our graph crosses the y-intercept when x equals 0, which is basically just telling us we need to plug 0 into our function. And when we do this, we see we get the constant term, or c of 1. So our y-intercept would be 0, 1. All right, so now let's actually try to graph this quadratic function that's in general form. Now we have enough information to finally graph our quadratic function that's in general form. Recall our vertex was negative 2, negative 3, and because of a being positive 1, we know that our parabola is going to open up. Let's now graph our x-intercepts. Our x-intercepts are negative, and I'm going to be guesstimating a little bit here, negative 0.30 and negative 3.7, and our y-intercept was 0, 1. And by connecting the dots, we can graph our parabola of x squared plus 4x plus 1. Again, as a reminder, the vertex here is negative 2, negative 3. We are opening up. We have our x-intercepts. And here at 0, 1, we have our y-intercept. Can we put this in vertex form now that we have our graph? Sure we can. We would simply write f of x equals x plus 2 squared. Now why am I writing x plus 2 and not x minus 2? Well, recall our vertex form is x minus h squared plus k. And so we are getting an opposite sign here inside the parentheses. So when we have negative 2, it actually in the parentheses will be x plus 2 squared and then minus 3. And this would be our vertex form for this parabola. All right, let's run through an example here, working with the vertex a little bit, all right, and talk about the parabolic path of a punted football. All right, when a football is kicked, the height of the punted football in feet can be modeled by this quadratic function, where x is the ball's horizontal distance in feet from the point of impact with the kicker's foot. All right, so in other words, how far has it gone? All right, we want to know what is the maximum height of the punt, okay? Well, how are we going to find this? Well, first of all, we need to get the vertex. All right, so we take negative b over 2a. Here b is 1.18 and a is negative 0.01, plugging it into the x-coordinate of the vertex formula, and I get negative 59 or 59 feet. All right. All right, so the maximum height of the punt occurs 59 feet from the kicker's point of impact. All right, that doesn't tell us yet what the maximum height is. It tells us where it occurs. The actual maximum height of the punt is taking 59 and plugging it into the function, in which case we get 36.81 feet. That's the maximum height of the football. All right, how far must the nearest defensive player, who is 6 feet from the kicker's point of impact, reach to block the punt? All right, this means, so let's put some English in here. This means we need to find the height of the ball 6 feet from the kicker. All right, in other words, plug in 6 for x. All right, so I'm plugging in 6, and I get 8.72 feet. All right, the defensive player must be able to reach 8.72 feet above the ground to block the punt. All right, in other words, he's got to have a pretty decent vertical, certainly better than mine. All right, what are the key points that you need to know from this lecture? You need to know general form versus vertex form. You need to understand the shape of a quadratic function, when a parabola opens up or down, using either form to graph a parabola, and able to solve for a maximum or a minimum, and able to solve for those x and y intercepts that I showed you.